Hello everyone, it's that teacher here, and today's lesson is going to be on equivalent fractions. Let's start learning. Welcome back to the channel everyone, thank you for watching. Let's dive straight into our lesson on equivalent fractions. Now, equivalent fractions are different fractions that represent the same value or proportion of a whole number. So, they have different numerators and different denominators, however, they equal to the same value, okay? So that's just a little definition of equivalent fractions. Now here is a visual representation of equivalent fractions. So I want you to see that visually, they all equal a half. It's half of each circle. However, the circle has been broken into many different parts, so the denominators are different. So for example, let's use our identifying fraction skills to identify these fractions, and so I can explain what I'm talking about. So the first circle is broken into two parts, okay? Now, one part is shaded, so that fraction is 1/2. Our next fraction has been divided into 4 parts. Now, we call those quarters. If you haven't seen my previous lessons on fractions, please go and check those out for a bit of foundational knowledge and understanding. However, once a circle or a fraction is divided into 4 parts, it is quarters. Now, we have 2 quarters here. So, 1/2 is equivalent to 2 quarters, okay? So you can see how it doesn't matter that the denominators and numerators are different. Some fractions will end up having the same value, as you can see from the circles here. Finally, our last circle has been divided into 6 parts. Now we have 3 parts that have been shaded, so our fraction here is 3/6. Now, you can see that 1/2, 2 quarters, and 3/6 are all the same value by looking at the visual representation of the circle. You can see that no matter how many times this circle has been divided, these fractions are all the same. They eventually equal the same thing, making them equivalent fractions. Now I'm going to show you another way how to do this using a fractions chart, okay? So for this example, we're going to highlight 1/2. Now, if you have a fractions chart in your class, you can use this, especially if it's laminated. You get that whiteboard marker, draw all over it because it rubs out easy, just so this helps you when you're learning equivalent fractions. Later in the lesson, we're going to go into the algorithm form of equivalent fractions, but this peels back the layers and really simplifies the process and gives you a visual aid to help with your understanding on the topic. So, you can see that this fraction is 1/2. Now, we have also now highlighted 2 quarters. You can see by using the fractions chart that this equals the same amount. So both black boxes, outlines that have been highlighted, equal the same amount. You can see one's not longer than the other. They stop at exactly the same amount, meaning that the 2 quarters here are equivalent. Now we're going to move to the 6ths like we did before. We have 3/6, okay? So 3/6 is equivalent to 2 quarters and 1/2. You can see there that the black outline that we've highlighted is equivalent. It's exactly the same size as the other fractions. Finally, I've included 12ths into our fractions chart just to show you here. Now I've highlighted the same amount of 12ths. We have 6/12ths. Now you can see that no matter the fraction, 6/12ths, 3/6, or 2 quarters, or 1/2, all of these fractions, while having very different numerators and denominators, equal the same amount. They are equivalent. They equal the same value, and they take up the same percentage of a whole number. So that is just a visual representation of equivalent fractions. We're going to show you one more. I'm going to show you one more example of this, but we're going to use a few different fractions. So in this example, I wanted to include not just 1 as the numerator. I wanted to include a variety of numbers to show you that numerator, denominator, if they're different, they can still be equivalent. So in this fraction, we've highlighted 2/3. So we have 2 parts of the bar, which has been divided into 3. So we have 2/3. Now 2/3 is equivalent to 4/6, okay? You can see that the bar is exactly the same size, so you can really see that these two fractions are equivalent. Now finally, we have 8/12. So if you look from the top fraction, 2/3, to 4/6 to 8/12, they're all exactly the same portion of the whole. The percentage of the whole that we have used is exactly the same. The numerators and the denominators are different. However, the percentage or portion of the fraction that we have is equivalent. So hopefully that visual representation of equivalent fractions has helped you. Now we're going to go into a more algorithm-based style of equivalent fractions. This is what you'll see more likely in your class, especially as you progress into the years of primary school or elementary school, whatever you call it in your country. In my country, Australia, it's primary school. This would be probably year 3, 4, 5, or 6. So it's content aimed at students in that age bracket. So this fraction, we have 1/3. Now, the trick to work out algorithm-based equivalent fractions is you have two numbers here. So remember, the numerator is the top number. We only have one of those. However, if you go down, we have both denominators. So we have both pieces of information, both pieces of the puzzle to solve what our equivalent fraction will be. So you need to think to yourself, what has happened? How much have you multiplied that 3 by to get 6, okay? So if you know your 3 times tables, which I'm sure you do if you've come this far, you would know that 3 times 2 equals 6, okay? Now with fractions, this is the golden rule. Whatever you do to the denominator, you have to do to the numerator, and vice versa. So whatever you do to one fraction, you have to do to the other. That's the golden rule of fractions. So in this case, we have times the 3 by 2, which means we also have to times the 1 by 2. Now, to get the answer, the missing blank above the 6 there, all we need to do is what we did. 1 times 2, that gives you 2. So the equivalent fraction of 1/3 is 2/6. That's how you work it out. Now I'm going to show you 4 more examples to consolidate that understanding so that when you get questions like this, you have no problem and you know that whatever I do to the bottom, I need to do to the top, or whatever I do to the top, I need to do to the bottom, okay? So in this question, 1/2 equals how many quarters, okay? Remember, we work with both sets of numbers. In this case, we have both denominators. So you know that if you're doing times tables, what do I have to times the 2 by to equal 4? Well, you know that is 2 times 2. Okay, 2 times 2 equals 4. Remember the golden rule of fractions? Whatever you do to the bottom, you need to do to the top as well. I always show my working out like I do here. I teach the students in my class to show their working out, because when you do this, it's very hard to make a mistake, because you keep track of what you've done, you show your working out, and it's easy to keep track of what you've done, okay? But whatever style of maths you have, if you don't need to do that, go for it. Maths is all about being comfortable with whatever strategy you use, okay? That's the beauty of maths. Now, 1 times 2 is 2. That's super easy. So your equivalent fraction for 1/2 is 2 quarters. Going on to our next fraction, we have 1/3 is equivalent to how many ninths, okay? So think about this. I have both denominators. I do not have both numerators. We need to work with the denominators. What has happened to that 3? What have we multiplied that 3 by to equal 9? 3, 6, 9. We've times that 3 by 3 to equal 9. And remember, whatever you do to the bottom, you have to do to the top. Exactly like this. 1 times 3 is 3. See, it's getting easier and easier, and hopefully this strategy is helpful. Now, our last fraction here, second last fraction, is 3 quarters equals how many eighths, okay? So what do we do to the 4? To make it 8. What has happened to that 4? What have we multiplied that 4 by to equal 8? You know that's 2. So we need to times the top number by exactly the same amount, which is 2. So 3 times 2 is 6, okay? So 6/8 is your fraction. Finally, we have 1/5 equals how many tenths? We have both sets of denominators, okay? Both sets of denominators. What have we done to that 5? What have we multiplied that 5 by to equal 10? Well, that's going to be 2. Whatever you do to the denominator, you have to do to the numerator. So that is 1 times 2. Your answer here is 2/10. So 1/5 is equivalent to 2/10, okay? So hopefully that strategy has helped you with your understanding of basic equivalent fractions, okay? Now I have given you some questions. I'm gonna show you the working out at the end. So if you get a bit of paper at home, write down your answers, okay? Pause the video here because you're going to mark your own answers at the end. And I know that if you follow that simple strategy, it's very hard to make the mistake. While we have you here, it's super important, fractions, one of the crucial elements is practicing your times tables. So I highly recommend that you practice, because knowing your times tables is a fundamental stepping stone, a fundamental key in your understanding of so many different content strands of mathematics. So practice those times tables, okay? That's my point. Let's go into the answers. So your answers are here to your questions. I hope you've done extremely well. In fact, I know you've done well if you followed our simple strategies from the video. Thank you for watching this lesson. We'll see you next time. It's that teacher. See you later.